Hey, Algebra 1 students, it's Mr. Wilsey again. I bet you're getting sick of seeing my face and working through these problems, but we're almost halfway through. So we're going to start looking at number 36 now in the Algebra 1 Practice EOC. I'm trusting that you've already tried these problems ahead of me and that now you are just checking your work. So number 36, we are given a graph, an exponential graph actually, of population growth, and we want to know what is approximately the population in the year 2000. This problem is really easy. All we need to do is first of all look down at the scale and interpret what the scale is telling us. Years since 1940. So that means that this is going to be 1940, this is going to be 1950, 1960, 70, and so on. This is going to be the year 2000. And then so on, but we don't care about what's happening out here. What we care about is the year 2000, okay? Now, to figure out what the population of this city is in the year 2000, all we need to do is go up from here, see where the graph is at that point, and the value of the graph is 900 at that point. But then we also need to look at the scale over here, and the population is given in thousands. So the population of the city in the year 2000 is 900,000, which is answer choice H. Number 37. Now number 37 looks scary because it has lots of words and it has a big table, and it's something that we really haven't studied in much detail. But what is most important, and I'm assuming you've already read through this and looked at the table, the correct answer choice is B. It is B because if you stick in these values of n representing the year, you'll see that if n is, for example, 2, then this expression here would give 2 minus 1, which is 1, so the expression would evaluate to 100 times 1.05 raised to the first power. Raising to the first power is just like, it's invisible, right? And of course, that is exactly what we have here, okay? And you can do the same exact thing with the other values of n. So this problem looks really scary, but it's ridiculously easy when you think about it. Number 38. Number 38, we are given a graph of a line, and we are asked to match that graph with the equation that generates that graph. Now, if you look at the answer choices, what this question is really testing you on is if you understand, first of all, slope. Do you understand that slope is the rise divided by the run? That's the first thing it tests you on. So let's go ahead and find the slope of this line. Let's see. Here's one point that's on the line, and here's another point that's on the line. Now the rise between those 2 points, so the vertical change, is positive 5, and the run between those 2 points, or the horizontal change, is positive 2. So that means that the slope of this line is rise 5 over run 2. 5 over 2. And then, of course, as a decimal, that is, well, it's not approximately equal to, it's exactly equal to 2.5. So the slope is 2.5, which means we know it's not G or F. Now look at the next thing that differentiates the remaining answer choices. In fact, these up here as well. The second thing this question tests you on is if you understand how to find the y-intercept. So your two possible choices, reasonable choices, would be this point right here, which is negative 5, or this point right here, which is positive 2. Well, you know that the number that goes into slope-intercept form is the y-intercept, which is negative 5. Ignore this 2 over here. The 2 is the x-intercept, but it doesn't belong in the slope y-intercept form. So the correct answer choice is H. Number 39 is a big, nasty compound inequality. So two inequalities joined by the word or, and we're asked to determine which of these numbers is a solution of the compound inequality. Now, the way that I'm going to show you how to do this is to simply work backwards. So take one number and test it to see if it's a solution of one of these inequalities or the other one. So I'm going to test negative 19. Watch how I type this into the calculator. So 3 times negative 19 replaces the x minus 19 greater than 5x, oh, not x, sorry, 5 times negative 19 minus 7. True. So the TI Inspire is telling me that this is a true statement when negative 19 replaces the x. Now let's go ahead and test the second inequality. So 6 times negative 19 minus 27 greater than 30 plus 3 times negative 19. False. Okay? So negative 19 works for the first inequality, but it does not work for the second inequality. Does that mean that we have to mark out A as a possible answer choice? No, that's not what it means. Because the word joining the two inequalities is or, the number only has to work for one inequality. It doesn't have to work for both of them. So the correct answer choice is indeed A. If you wanted to, you could be a little bit more confident in your answer and test negative 5, positive 5, and 19. But what you'll find is that your TI Inspire would say false every time you type these in. Number 40 here, we have a giant table here, and we are asked to find the value of the table when we're talking about 13 ounces as being the weight of our package. So if you look closely at this table, you'll see that the postage rate increases by 0.17 each time. So it increases by 17 cents. This is true for every single row. And of course, the weight in ounces goes up by 1. So that means that the rate of change for this table is $0.17 per ounce. So we can just extend this table, 11, 12, 13, and 13 is the magic number that we want. So we would add 0.17 here to get 2.87 for 11 ounces. 12 ounces we would have 3.04, and then we'd have to add another 0.17, 3.21, to get the postage rate for 13 ounces. So the correct answer choice is H. In number 41 here, we're given a table, and we are asked to find the probability that there will be a tie between Carlos and Amanda. Now, in order to find probability for this situation, we need to take the number of times that the two players tied, 3, and divide that by the total number of times they played, which is 4 plus 5 plus 3. So 3 divided by 9 plus 3, 12. 3 over 12 is 1/4. So the correct answer choice is A. In number 42, you are given a graph of a line, and you are asked to determine what is the equation of that line. Now, first of all, look at the answer choices. We are basically deciding on signs here. So is the slope negative or positive? Is the y-intercept positive or negative? Okay. So you can just look at the line and say, oh, it's going upward, which means it has a positive slope. So with that information, you can immediately mark out f and g. Isn't that nice? And actually, you can immediately mark out the fact that the y-intercept is negative. Do you see that? H must be the correct answer choice because the y-intercept is right here, which is 75, right? It's midway in between 0 and 150. So this problem was actually a lot easier than I expected it would be. Now, in contrast, number 43 looks to be an extremely difficult problem. I really don't know how an Algebra 1 student could figure this one out on their own, and actually, without just blindly guessing. So let me just briefly tell you what you would do. First of all, recognize that this is not just a rational expression, but a rational expression with a radical in it, which is pretty radical. The way that you would do this is like any other rational expression. First, you would factor, then you would cancel. So the top you would factor, you would have to factor it the long way, or you can just kind of factor it by eyeballing it. So in order to get the 2x squared, I bet there's going to be a 2x and an x in the factored form. Now how do we get a 5? Well, the only way we could get a 5 right there would be a 1 and a 5. But the question is, does the 1 go here or here? Let's try to eyeball it. What if it goes right? Let's test that. See if it works. 2x plus 5 times x plus 1. If I multiply this out, does it give me back this? Well, let's see. 2x times x is 2x squared. 2x times 1 is 2x. And then 5x. And then 5. So I just quickly use FOIL. And yeah, hey, 2x plus 5x gives 7x. So I just happened upon the correct factorization there. Again, you could factor this the long way if you wanted to. Now, divide that by the square root of. Now, this is pretty disgusting, but you can factor it the long way as well. I'm just going to try to factor it by eyeballing it as well. To get 4x squared, one way is to have a 2x here and a 2x here, right? Now, how do we get a 25? Well, a 5 and a 5? Wouldn't that work? Both of them being positive? Let's check to see if this would work. 2x times 2x is 4x squared. 2x times 5, 10x. And then another 10x. And then 25. Yeah, 10x plus 10x is the 20x, which is right here. So it works. So again, I just kind of eyeballed how to factor the bottom. Now, 2x plus 5 times 2x plus 5 is the same thing as, do you know what we can replace that with? I hope you said 2x plus 5 in parentheses squared. Now look at what we have here. We have the square root of a quantity that is being squared. Well, those just cancel each other out, right? So that's what we're left with. So we have successfully factored. We've successfully gotten rid of the radical. Last step, cancel. So the only thing that's left over is x plus 1, which is answer choice A. Alright, number 44. You will actually not see any problems like this on the EOC, where you have to determine the area of a shape on a plane grid. But in case you were curious, the correct answer choice is G. Alright? So moving on to number 45, which of these four graphs best shows a positive linear relationship between the variables? Well, I hope that you remember that a positive linear relationship will look kind of like this. Answer choice D. It's linear because the points in this scatter plot kind of sort of follow a trend line, right? They kind of all lie along a line. They don't necessarily lie exactly on a line, but that's okay. And it is a positive linear relationship because this trend line has a positive slope. All right, so that's easy enough. Number 46 here is another problem that you will not see on the EOC, but in case you are curious what the answer is, the correct answer choice is G. Okay, let's move on to number 47. So we are given an equation, y equals 8x plus 7, which represents the distance that a bicyclist is from home after he's ridden x hours. So we want to know, what does the slope represent in this situation? Now the slope of this equation is 8. So what does that slope represent? Well, the correct answer choice is D. The slope represents the speed of the bicyclist. Since the distance is measured in miles and x is measured in hours, 8 means that the bicyclist is traveling 8 miles per hour, right? Because if you multiply that number, 8, by the number of hours, let's say he rides for 4 hours, so if x equals 4, then he will have ridden 32 miles. Okay, and of course the 7 represents how far he starts away from his home. So he starts 7 miles away from his home. Number 48 here. I hope that you recognize that this is a Pythagorean theorem problem, because we have a right triangle, it's an awful triangle, and we want to know what is the length of the hypotenuse, what is the length of this diagonal here. So to set up the Pythagorean theorem, you would take 3 squared plus 8 squared, and that is equal to the length of the hypotenuse, c squared. So 9 plus 64 equals c squared. 64 plus 9 is 73. So that means that c is going to be the square root of this. So what's the square root of 73? 8.5. So looking down at the answer choices here, it looks like the closest one is going to be answer choice G. Number 49 here requires us to simplify this expression, which has variables raised to different exponents. Now, I hope that you remember the rules of exponents and how to deal with these. First thing that you should see, let's deal with the x's first. How do we simplify x to the 6 divided by x cubed? Well, what do we do with the exponents here? Well, if you're dividing x to the 6 by x cubed, you would subtract the exponents. 6 minus 3 equals x cubed. So you know that you're going to have x cubed in your final answer. Well, how about the y's? How would we deal with that? Well, one way that you could deal with it is by doing the exact same thing that we just did. We could say y raised to the 2 minus 4th power, which is y to the negative 2nd power. Or another way to visualize this is that you have y times y, is y squared at the top. Y to the 4th is going to be y times y times y times y. And then you can cancel out these two y's and these two y's, which leaves you with 1 over y squared. You see that? Now, of course, if you remember the rule of how to deal with a negative exponent, if you have y raised to the negative 2nd power, that is the same thing as y to the positive 2nd power on the bottom of the fraction, which is, of course, exactly what we get when we think about it this way. Okay? So we know that we're going to have x cubed on the top of the fraction, y squared on the bottom of the fraction in our final answer. Now let's deal with the z's. Z to the 9th divided by z cubed. Subtract the exponents. 9 minus 3 is a positive 6. So that means it's z to the positive 6 power. And since we're multiplying by z to the 6, that's the same thing as if the z to the 6 was hanging out with its buddy z cubed up here. Now how do we deal with the numbers? 3 divided by 12. Well, you know that 3 divided by 12 can be simplified as 1/4, right? So if we bring this 1/4 over to the answer that we're building, you can see that 1/4 is just multiplying the rest of this, so we can kind of join the fraction here. So it's going to be 4 times y squared in the bottom, 1 times everything at the top, but multiplying by 1 is kind of invisible. So this should be our final answer right here. Now, does that match any of our answer choices? Look very, very carefully. Well, yeah, sure. It matches answer choice B. We want to know which of these pairs of values will make this quadratic equation true. So one thing you could do is simply work backwards and just like plug in -6 for x and see if it makes this equation true. And then do the same thing with 2. So let me show you how that would work. -6 in parentheses squared plus a -6 minus 12, is that equal to 0? False. So -6 does not make the equation true. So we don't even need to test to see if 2 makes it true, because f is automatically out of the running, because the AND word means that both -6 and 2 have to make the equation true in order for f to be the correct answer. But if -6 doesn't make the cut, it doesn't matter if 2 does. Now, you could test the other ones the same way, or you could do this the way that I taught you, which is by factoring. So if you factor this and turn it into a product of 2 binomials, the way you would factor this is, let's see, shortcut tells us x and x. So there's going to be a positive something and a negative something. Positive 4 and -3, right? Because these two numbers, they multiply to equal the -12, and they add up to equal +1, which is the number multiplying the x here. You see that? Now, once you have the factored form of this quadratic equation, you can use the zero product property, which says that either x plus 4 is 0 or x minus 3 is 0. Which means, of course, that either x is -4 or x is +3. And so that matches answer choice G here. See that? And that's it. We are done. I just wanted to show you my face one last time to let you know that I did not outsource this video to India or anywhere. I hope that we are one step closer to making you feel really comfortable with the EOC, and that you are going to ace it. I know you can do it, so prove me right.